Now we are going to solve a question that is based on the equation of motion and also the free fall, that is the vertical motion under gravity. So here they are using that a parachute is used to deliver a box of supplies. The parachute is attached to a box. The parachute and the box dropped from rest from a helicopter that is hovering at a height of 520 meters above the ground. So here I can just make a diagram like that. So here this is that helicopter hovering. It is 520 meter above the ground. So this one is our ground, and here the helicopter is hovering. So the boxes comes from this area. Okay. Next, the parachute and the box falls vertically and freely under gravity for 5 seconds. Then the parachute opens. So it starts moving down and it reaches a particular position. So during this, the time is equal to 5 seconds. After that, the parachute get open. Okay. So the parachute open here. Now here they are mentioned instant from the instant the parachute opens, it provides a resistance to motion of magnitude 3200 Newton. So after the parachute get open, there is a resistance force in the box. So that resistance force is 3200 Newton. Okay, and also here they are mentioned like the box continue to fall vertically downwards after the parachute opens. So it is continuously moving down. Okay, the parachute and the box are modeled throughout the motion as a particle of mass 250 kg. So this is 250 kg. So we can able to write it as 250 times g, that is a weight force towards downward. So this is given in the question. Then find the distance fallen by P in the first 5 seconds. So P means it is a particle. We consider as the parachute and the box as a particle. Okay, so that we need to identify the distance fallen by P in the first 5 seconds. So already all the details are in our diagram. Here this is the position. So it starts from 520 meters above the ground, and the first 5 seconds it is moving with that vertical motion. So there is no resistance force, and there is no resistance for or acting on the object, right? So initially it is at rest, u is equal to 0, and the time t is equal to 5 seconds. So we need to calculate how much the distance it is fall. So here we know that it is downward with the vertical motion. So a is equal to 9.8 meter per second square. So we need to identify that s value. So s is equal to ut plus half at square. It is the equation of motion formula. So u is equal to 0. So 0t is 0. Then 1 by 2 times 9.8 times 5 square. So we can type it in the calculator. So this will be 1 by 2 times 9.8 times 5 square, and our answer is 122.5. So either we can able to write in the 2 significant figure or the 3 significant figure as your answer. So I just write it as 3 significant figures. So it is 123 meters. So for the first 5 seconds, the distance traveled by the parachute and the box is 123 meters. Then the next question we need to solve. Find the speed with which the P lands on the ground. So after it reaches that 5 seconds, its velocity is changing. That means the acceleration is changing because there is a 3200 Newton force is applied as a resistance. Okay, so the same acceleration we can't able to use after that 5 seconds. So we need to identify a new acceleration, that is a1. So that we need to identify the initial velocity for the parachute and the box, after that 5 seconds. So this is separate calculation, and this one we need to do the separate calculation. So the first part we can able to calculate that velocity. So final velocity we can calculate, then only we can able to go for the second portion, right? Because during that parachute open, there is a 3200 resistance forces acting on the object. So now V is equal to U plus AT we need to use. So here again the U value is equal to 0, we know that. And then here it is 9.8 times, the T value is 5. So 9.8 times 5 is, the value is 49 meter per second. Okay, so after that parachute open, the initial velocity, so I can write it as u1. The second conditions I write it as u1. Okay, so it is 49 meter per second, and then we know that the distance it should be covered like that, that is s1 is equal to 520 minus 122.5, because what we calculated, that is 520 minus 122.5, we need to use the exact value, not the round off value. Okay, so that is s1 is equal to 520 minus 122.5, and we want that a value, then only we can able to calculate the final velocity. So how to find the a value? Already we have the diagram like that. This is the diagram after the parachute open. So the box has weight force, that is 250 g, and then a resistance force 3200 Newton. It is moving downwards. So we can able to apply the downward directional forces are positive because it is moving down. Force is equal to mass multiplied by acceleration. So this value will becomes 250 is a positive, and then minus 3200 it is negative. Then the m value is 250 times the new acceleration. So that's why I write it as a1. So from here we can get that answer as 250 times 9.8 minus 3200. So this will be minus 750 is equal to 250 times a1. So a1 is equal to minus 750 divided by 250. It will be minus 3 meter per second square. So we calculated that minus 3 meter per second square. So once we calculated that value, so we can able to use it like u1 is equal to 49 and s1 is equal to 520 minus 122.5, and then a1 now calculated as minus 3. So our aim is to calculate that velocity when it hits the ground. Velocity when it lands the ground. So the value we can able to calculate like v1 is equal to v1 square is equal to u1 square plus 2a1 s1. So u1 square, that is 49 square, plus 2 times minus 3 times the s1 value is 520 minus 122.5. So we can get that 49 square plus 2 times minus 3 times 520 minus 122.5. We are getting that answer as v1 square is equal to 16. So v1 is equal to square root of 16. Our answer will be 4 meter per second. So that is the second answer. We have it. Find the speed with which P lands on the ground. So now we need to calculate the total time from the instant when P is dropped from the helicopter to the instant when P lands the ground. So from this point to, so starting point to end point, the total distance travel, right, the time taken we need to calculate. So already they mention when it left from the helicopter and before opening that parachute, the time taken is 5 seconds. Then we need to calculate the after that parachute opens and then it reaches to the ground. So that time taken we need to calculate. So that is T1 we need to calculate. So the same values. So with the help of this U1, S1, A1 and then V1 we can calculate the T value, so that we can use V1 is equal to U1 plus V is equal to U plus AT, that formula we can use. So this is 4 is equal to 49 minus 3 times T1. So this will be 4 minus 49 divided by minus 3 is equal to T1. So the answer becomes 4 minus 49 divided by 3. So it is divided by minus 3. So your answer will be 15. So already we have the total, already we have the time. So that is total time is equal to 5 plus 15, that is equal to 20 seconds. So you know that this 5 seconds it is before opening the parachute, and this 15 second after open the parachute, and then at the instant when it reaches the ground. Okay, so this is our answer for the C part, right? So this is for the C part. Now we need to sketch a speed time graph for the motion of P from the instant when P dropped from the helicopter to the instant when it lands on the ground. So we need to sketch a speed time graph from the starting point to it reaches the ground. Okay, so here this is a D and we need to sketch a speed time graph. Here we need to write the speed in meter per second, and here it is time. When the time 0, it is in the rest condition, so it's here. But when it starts moving up, its velocity becomes 49 meter per second. Okay, it reaches that 49 meter per second, that is the final velocity when the time is 5 seconds that we calculated, that is the first value. So it is increases to that 49 meter per second during its 5 seconds travel, and after that the parachute opens. When the parachute opens, the acceleration will be the negative acceleration, and it reaches 4 meter per second in the next 15 seconds. So again it starts fall and it reaches that 4 meter per second in that 20 seconds. So it is a positive curve, it is a positive line. So here that it is a acceleration period and then it is a deceleration period after the parachute open. So this is the speed time graph for that particle is moved from the instant dropped from the helicopter to the instant it lands the ground.